Hello. Today we'll be going over question 1 in on page K53b. So let's read the problem. Given f of x is equal to x minus 5 squared plus 3, and we have an interval. So a is less than or equal to x, which is less than or equal to a plus 2. Find the minimum value. Okay, so it's important to recognize that for this question, we don't have a defined interval because a is a constant. So depending on what a is, say a was equal to 1, our interval would then be 1 to 3. Then we will have a specific minimum value. And that might differ from if a was equal to, let's say, like 10, if the interval was from 10 to 12. So since we're just given a, and a is a constant that we cannot really define, we're just going to try to generalize the minimum value at certain ranges. So I want to find, hey, when is my minimum value going to be the right hand side of my interval? When is my minimum value going to be on the left hand side of my interval? And when is my minimum value going to be, maybe, let's say, the vertex or something like that, right? Because it's important to note that, so if we draw this graph out, let's say x, y, the vertex is going to be at, hopefully you guys can recognize this from previous practices, it's going to be at x equals 5, and then y is equal to 3. And then I will go ahead and graph, just a general graph, like something like that. But this is located, this axis of symmetry is at x is equal to 5. So the way I like to think about these, I guess, intervals is think about them as two sliders. So just think about, if you want to look at my fingers, like here, they're sliding across the parabola like this. And when is the right hand side of the interval, so a plus 2, when is that going to be higher or lower than a, and vice versa? And that's going to define the minimum value. So let's just try to conceptualize what we're dealing with. So let's say that a, which is the left hand side, it's always going to be the left hand side of the interval, and let's say a plus 2, which is right here. In that case, the minimum value, I think we could agree, would be at f of a plus 2, because this is lower. And that would hold true, so that would hold true. The a plus 2 would be the minimum value until a plus 2 is here and a is here. Because now the minimum value can be defined as not just f of a plus 2, it can be defined as specifically the vertex. But we know that as long as a plus 2, so this right hand side of the interval, keep that in mind, as long as a plus 2, so we'll call this scenario, we'll label this scenario A. As long as a plus 2, this right hand side of the interval, is not passing or not touching x equals 5, so that's the same as a is less than 3, then we know that the minimum is just always going to be, we can generalize it and say it's going to be at f of a plus 2. Okay, and then f of a plus 2, we can just find that by plugging in a plus 2 into x of the original equation. So that'll be equal to a plus 2 minus 5 squared plus 3, which is a minus 3 squared plus 3. And then I'll go ahead and write this over here. And then that's just equal to a squared minus 6a plus 9 plus 3. And then a 9 plus 3, this can be added to give us plus 12. So that is going to be the minimum value as long as a is less than 3. So say a was, let's say, 2 in this case. If a was equal to 2, let's just give a hypothetical. if a was equal to 2, then my boundaries would be from x is equal to 2 to x is equal to 4. And in that case, I know that the minimum is going to be, I would plug in a equals 2 into here, and that would give me my minimum value. So I could plug in 2, I would get 4 minus 12 plus 12, which would be equal to 4. And that makes sense, right? Because the minimum would be at the right-hand boundary, and if you want to plug in x equals 4 into this original function, you would get an output of 4, like we got. So that's the first case scenario. But let's consider a second possibility. So let us say that, just erase my whole graph. Okay. Let us say that the a plus 2 now crosses x is equal to 5. So it's past x is equal to 5. It's on the right hand side of it. And a plus 2, a is here. So this is a plus 2. This is a. Now we can say that the minimum is at the vertex, right? It's a defined value. And we know that that holds true. So remember, think about the intervals as sliders. Think about, so when is the minimum not the vertex anymore? We could say that, so as long as a and a plus 2, they kind of trap the vertex, we know that the minimum is going to be at the vertex, right? Because, oh, I just erased that whole thing. Because as soon as, let's say this is a plus 2, and this is a, as long as these two boundaries don't trap the vertex anymore, we cannot define the minimum to be the vertex. The minimum to be the vertex, because the vertex is not included in our interval. So how do we generalize that in an inequality, or summarize that? We can say as long as our interval, so a is less than or equal to 5, which is less than or equal to a plus 2, which is basically saying as long as these a values, our intervals are in between 5, then the minimum is going to be at the vertex. So that's, the vertex is f of 5, which is at y equals 3. And then you could separate this into two different inequalities, like that. And then this one you can solve to be 3 is less than or equal to a. So that's the second case, sorry. And now we have to address a third case. So the third case is similar to the first one. So we know that as long as a and a plus 2 are on the right hand side of a vertex, we can generalize what the vertex is. We can say that because a plus 2 is always going to be higher than a, or f of a plus 2 is going to be higher than f of a, as long as a is past x is equal to 5. So we can say that as long as a is greater than 5, so as long as the left hand side of the interval is past x is equal to 5, we know that the minimum is just always going to be that left hand side of the vertex. Left hand side of the interval, sorry. So it's going to be at f of a, and then if we plug that into our original expression, that'll be equal to a, so I'm going to plug this into our original equation, a minus 5 squared plus 3. If you wanted to simplify it, that'd be a squared minus 10a plus 25 plus 3, and then 25 plus 3 is equal to 28. So yeah, that's the answer. So there, you could think about it as 3 different answers, but you must address at what values of a each minimum at what values of a we can generalize each minimum at. And that's it for that one. Alright, take care. Bye bye, good luck.